So x is natural log 3 plus 2 root 2. And this one is x equals natural log 3 minus 2 root 2. Done. Those are my answers. Yes?
Is there going to be a question like this in the test?
Yes.
Why, you don't?
I understand it. I just don't know if I can solve this for myself.
You could do it.
Oh.
You could do it.
No.
You could do it. You can. You can. You can do it. No, look, I mean, what I'm gonna want to see on the test is that you recognize how to turn an exponential equation into a quadratic. That quadratic might be able to be factored, but you need to be prepared to use quadratic formula if you can't factor it. And then the rest is just this little loopy thing. Yes?
I don't really see too many like problems like this in the homework. Is
Oh,
it
okay.
possible like you send out a list of like say, hey, here's some problems you can practice that are like this?
Yeah, this is actually number 89, no, number 90 in the book. So I'm going to stay within the context of what's in the book. I'm not going to go outside of what's in here.
No, I'm just saying like, hey, here's some practice problems that are just.
Your practice is the homework,
Well,
right?
I know that.
And then I'll give you 40 minutes next class for the review. I'm just saying, look, we're at a point right here in this class. Y'all are getting close to the point where you're going to be moving on to pre-cal.
I'm just asking for more examples like this that we can practice on our own for homework.
Okay, well, this was number 90. If you want some practice similar to this, you can look at number 89, 91, and 92, are very similar to this. In fact, the only difference between 89 and this one is that, you know how we said all that stuff equals 3? It was equals 1. So things work out a little different in the algebra. All right, we good? Happy? You like it?
I don't care about the example. I just want to know more problems.
Let's do another one. How about 2 times 49 to the x plus 11 times 7 to the x plus 5 equals 0. So let's talk about some of the things that students do that are not allowed. Students will multiply 2 times 49. Why can't I do that? That's right. And think of order of operations. What order of operations says you must do exponents before multiplication, right? So I'm supposed to raise 49 to some power before I multiply by 2. And if I don't know what the power is, then you can't come multiply by 2 right now, right? So that 2 and 49 are separated. You can't put them together. Same with the 11 and the 7, right?
Can't you use the 7x to the x or something?
Okay, for what? As what?
I was thinking substitution.
You want to make a substitution that u is 7 to the x?
No, I was just looking.
That's correct.
Oh, okay.
That is correct.
You could do 7 to the x to the power of 7. Oh wait, no, not the power of 7, the power of 2.
Yeah, what about that 49? It's actually very important that that 49 is 7 squared.
Yeah.
Right? I could rewrite this as 2 times 7 squared to the x, right? Plus 11 times 7 to the x plus 5 equals 0. And then 7 squared to the x is the same as 7 to the 2x, isn't it? But that's the same as 7 to the x squared. It's weird that it works this way, but it's true.
I just
Right?
went straight for the second one.
That's okay. That's okay. I just want to make sure everyone's clear that 49, this 49 to the x is the same as this to this, which I can switch the order and put the x here and the 2 there.
Because I was realizing, just like you did over there, I was like, oh, well, they're the same because the moment you put them together, they're interchangeable.
That's right. Yeah, at this point, if I put parentheses around the 7 to the x, you can kind of see where the u is now. Yes,
Then when you put u, can you use 2 and 11 as a coefficient?
that's what we have to do. Yeah.
So you need 2u plus 11.
Question? Maybe I can do it this way. X squared to the third equals x to the sixth, but that's the same as x cubed squared. I don't know if that makes sense.
It's just like saying how.
This is x squared times x squared times x squared, isn't it? That's what cubing something is. This is x cubed times x cubed. They're the same thing, right? 6 factors of x here, 6 factors of x here.
So it's
Does that help?
Saying how 3 times 2 and 2 times 3 is x.
It's commutative. It doesn't matter what order, yeah. All right, so the quadratic that we're going to get here is, if we make u, 2u squared, thank you, 2u squared plus 11u plus 5 equals 0. I'm thinking this might factor. 2u, u, 5, 1, is that right?
It'll do it. Positive on both sides. It'll do it.
Oh man, we're going to get 2 negative numbers, aren't we?
U is negative 1/2 and negative 5.
Uh-oh.
No solution.
No solution.
That's it, we're done.
No solution. You see why there's no solution? Both negatives. So 7 to the x equals negative 1/5.
No. It's not 1/2. It's not 1/2.
Where? Oh, 1/2. Thank you. Negative though, but it is negative though, right? It is negative though, right?
It's still negative.
So it's still no.
So still no solution. So this equation has no solution. Now, that's kind of boring. What would have happened had this right here been a minus, 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 minus? This would have been minus, and then this would have been plus and plus. Then you would have been able to do what? Log on both sides and work it the rest of the way. I most likely won't give you one that has no solution at all. I mean, I will force you to actually do this step. All right. We all right with that?
I feel more comfortable.
All right, so those are exponential equations. The other type of equation that we still need to do today are logarithmic equations, which we've looked at a little bit, but I have always found these to be a little bit easier than the ones we just did. So I saved them for last. So log equations.
This one chapter.
Same chapter, same section, 6.6. So let's start with the very simple log equation. Log base 3 of x equals 2. So notice where the x is.
So then x would be equal to 3 squared.
X is 3 squared.
Yeah.
But notice, okay, in the previous problems, the x's were trapped up top and we had to get them down, right? Here, with a log equation, your x is trapped in a log and we have to get it out of the log. So the best way to get an x out of a log is to actually do that loop.
Yeah, so 3 squared x is 9.
So 3 squared is x. So 3 squared is x. 9 is x. And that's it. Now, we do have one thing here. We do have to check our answers in log equations. Exponential, we didn't. But log equations, you must check your answer because you can get extraneous solutions. So let's just check real quick. Can you plug 9 into this log?
Yeah.
Yes, because that'll be a positive number when I plug in 9. So I don't really need to go any further. It's good. Now, obviously, they're not going to be that easy, right? So let's crank it up a little bit. How about log 3x minus 5 equals 2?
It's the same. You just.
So 3x minus 5 would be equal to 10 squared.
10 squared, good. So because I did not put the base here, you have to remember the base is 10. And then you can do the loop. 10 squared is 3x minus 5. So 100 is 3x minus 5. 105. 105 is 3x. 105 thirds is x. Is this straightforward? No issues so far? And we could check it. If you plug that in, you'll get, see, look, if I plug this number in, this number is like 30 something, right? Okay. 3 times 30 something, like that's minus 5, that's positive, right? That's all I care about. I've got a positive number in here. Not that this is positive, that when I plug that in, the argument remains positive. Understand what I'm saying? Because let's just say we went through the work and this came out to be 2. That doesn't mean that it worked. Well, that would work. What if it was 1? Sorry. If it was 1, we would say, oh, it's positive, it works. No, that's not what you do. You have to plug 1 in, and then that would give you negative, and that wouldn't work.
So say it doesn't work, it would just be
No solution. Yeah. We're gonna see something like that.
This seems a little bit easier compared to the others so far.
It is, so far. You like these, huh? Okay, how about 2 log base 2 of x equals log base 2 of 5. Now you're seeing 2 logs in the equation, aren't you?
Well, yeah, you just move it over, get it equal to 0.
You could move them over and get it equal to 0. That would be okay. But I want to instead use this property. Log base a of x equals log base a of y means that x must be y. Now we did this before.
X equals 5.
Well, x squared.
Hold on. We did this before back when we were doing like 2 to the x equals 2 to the 3. We said the x and the 3 had to be the same, right? X had to be 3. And we were allowed to do that because we said that these were one-to-one functions. So I want to use this property since the log appears on both sides like this, but I cannot have coefficient in front of this log. So move that up as a power.
So it would be x squared equal 5.
So you get log base 2 of x squared equals log base 2 of 5. And now you can say this is the x, this is the y. So x squared must be 5. Nope, you're not squaring this one. We didn't have a coefficient to bring up. We're just matching the insides of the logs now. Get it?
Yeah.
So x equals plus or minus root 5. I do plus or minus because I initiated the square root on both sides. I need to check my answers. Where do I check them? Original problem. If I plug root 5 in here, is that okay? It's a positive number, right?
Yeah.
If I plug negative root 5, does that work?
No.
No. Negative root 5 does not work because I can't plug a negative into a log. So x equals root 5 is your only solution.
Do you want it, the final answer is root 5, or do you want the decimal?
Root 5.
Will the decimal be counted wrong?
It won't be wrong, but we like exact answers without the rounding. You know, unless we're trying to graph that, like, you know, plot that on a number line, leave it in exact form. All right. Keep turning the screws here a little bit. How about this one? How about 2 log base 3 of x plus 4 minus log base 3 of 9 equals 2. That problem's a little too easy, but we'll keep going. We'll do it. How is this problem different than the one before?
You have 2 logs on the same side.
2 logs on the same side and a number on the other side, right? If you look at the previous problem, what was the base?
It's 2.
2 of x equals log base 2 of 5, right? I could have moved both of them over to one side, right? And got subtraction between the 2 logs, and then I would have had a 0 on the other side. I could have done that. That's almost like this, except I don't have 0, I have a 2, right? Any ideas on what I could do on the left side?
Well, you can take the 2 and put it to square.
We take the 2 up as a squared,
And then make it a rest,
Yeah.
subtraction.
and then you could turn the 2 logs into 1 log with subtraction turning into division. Do you agree?
Yes.
So these 2 logs, now what I'm doing is I'm using the properties of condensing, right?
Log base 3.
I'm going to write the original problem up here because I'm going to need it when I check my answers. Okay, so this is going to become log base 3, a single log, division inside, x plus 4 squareds on top, and 9's on the bottom, equals 2. Now we have a single log, so what? Go ahead. No, that was right. What? You are close. I thought I saw you go like that.
Yeah.
That
So then 3
this is your base. You can't.
3 squared is equal to our
3 squared, yes. 3 squared is this, yes. That's right. But you said multiply, so I was a little concerned about that. You're doing that loop, which is just a way of rewriting it. You're not technically like multiplying both sides by anything. So this becomes 3 squared, not 3 times 2, right? 3 squared equals
X plus 4 squared.
x plus 4 squared over 9.
and then
And then
remember that divide by 9, we can multiply each side by 9.
Let's multiply each side by 9.
Get rid of the 9.
So 9 on this side, 9 on this side.
So, yeah.
That's already a 9.
Yeah, so now it's 81.
81 equals x plus 4 squared.
Take square root.
Take the square root, which means you're going to have to initiate a plus or minus, aren't you? So what's the square root of 81?
9.
So plus or minus 9 equals x plus 4. And then subtract 4 on both sides. Plus or minus 9 minus 4 equals x. I have 2 different answers there, don't I? Any questions, though? So far, we're almost there. What's one answer? Potentially. 5. And then the other answer, x is what?
Negative 13.
Negative 13. Now don't throw out the negative 13 yet.
Oh, because it
Only if when you plug it in, it messes it up. And when I say plug it in, go back to the original problem. So if you plug 5 in here, 5 plus 4 is 9, that's okay?
Yeah.
If you plug negative 13 in here,
That is not
that does not work.
Doesn't it? Because you're going to square it?
We have to look at it before we do any simplification, any properties. That's why I rewrote the original, so that we don't accidentally, because if you leave it up there as a squared,
Then you square it.
then you square it, then you'll think you don't have a problem. So this is it. Doesn't work in the original equation.
So, again, why can't we just bring up the 2 to square?
You can, but let me try and illustrate this with the maybe an easier example. I'm going to define 2 functions for you, okay? I'm going to define the function f of x equals 1 versus I'm going to compare that to a different function g of x, which equals x over x. I think I may have used this earlier in the semester. What is the difference between those 2 functions?
There is none.
There is none? If I graph this f function right here, it's always 1, right? So it always spits out 1. So it looks like this, doesn't it?
Yeah.
And I can plug anything I want into that. Now let's graph this one. So if I plug in 1, I get 1 over 1. If I plug in 2, 2 over 2, which is 1. 3, 3 over 3 is 1. I can do that for all negative numbers also. So this should graph the same exact thing, except I can't plug 0 in, because 0 over 0 is undefined. So what I would have the same exact picture,
Except you'd have a hole there.
except I'd have a hole here, right? But what if you looked at this problem and before you did anything, you simplified it? What if I said, oh, but x over x is 1? Then what you've done is you've eliminated the domain problem, and that's a mistake. You are not allowed to cancel this, okay, unless you promise me this is your new answer you somehow tell me what couldn't be used here, okay? So you would have to say this is equal to 1 as long as x is not 0. If x is 0, it's undefined. So you have to be real careful with simplifications and algebraic manipulations that they can jeopardize your domain if you're not careful. So in the original problem here, this is the way it was stated. All right, this is the way it was stated, so that's what I have to go back to. Now, if someone had given me this problem and it started like that, that's the way it was presented, negative 13 would be okay. Understand? It's tricky, but it's an important.
So because it was presented with the 2 before the log, then we can't consider that one when we're checking your answers.
We can't consider this one when checking our answers. We have to consider the original one. Just like over here, I'd have to consider the original function before I did any simplification, before I can check domain. All right. So I'll give you an option. We've got about 20 minutes left. You want to do a couple more of these log equations, or do you want to see the proof of the quadratic formula?
Log equations. No, it's going to be on a test. Log equations.
Okay, all right. You're not going to hurt my feelings. All right, let's keep going here then.
We're not entitled to a voter?
No vote. I agree with that.
That's not true. But my friend on the left side wrote she's definitely not right.
From my sheet.
Log base 6
Standing on the other side, she's right.
of x plus 4 plus log base 6 of x plus 3, x plus 3 equals 1.
Oh, hey, I got a job. Remember how you do for reference?
Yeah. Oh, good. I'm surprised because they called me and it wasn't good. I'm kidding with you. That's good. I'm happy to hear that.
Now I get to be a doctor's assistant.
Yeah? Have you started it yet? Like, have you? No?
Clinical training.
Okay.
Be a
That's a good thing because you can, you'll see if that's really what you want to do. All right, so what are your ideas here?
Foil.
How do you mean?
Well, you're going to combine
The two logs into one?
Yeah.
Addition turns into multiplication, two logs become one.
Yeah.
So I can do that. I have no problem with that. X plus 4 times x plus 3 equals 1. I think you said FOIL them, you mean like multiply them together? Okay, can we go any further? I mean, I know I can multiply those together, but what will my next line be?
6 to the power 1.
Do the loop now, right?
6 to the power 1 is that other
Is this thing in here, right?
Oh, okay.
So 6 to the power 1, which is just 6, is this stuff which I think you multiplied already for me and got
x squared plus 7x plus 12.
that. Everyone see that? And then this is just a quadratic, isn't it?
Bring the 6 over. And then
Bring the 6 over and then start working. I'll finish it, but does everyone follow that? Okay. X squared plus 7x plus 6 is 0. I believe it factors. Six. What are our two answers? -6 and -1. Now be very careful. You do not say no solution right now. You remember when we did the substitution a second ago and we said, whenever we get negative answers, no solution, totally different problem, right?
6 won't work, but negative 1 will.
So we check these into the original. So -6 you say doesn't work? Yeah, it fails right here. We don't need to check anything else, but you can see it also fails there. -1 works. Works. Now, do you see how important it is that you don't look at this and say, oh, it's negative, doesn't, no answer? You have to plug it in first. And it does work when you plug it in. So we have one answer, -1.
It's only for logarithmic, right? So we have to plug it in.
Mm-hmm. You don't have to do it for the exponential. I'm just going to make one up. I'm thinking of like a problem that I would put on a test.
Yes, this exact same problem's gonna be on our test.
Learn this problem, do this problem, learn this problem.
I hope this works out. Normally I would have a little more time to check it to make sure it's going to work, but
How much you wanna bet on the test you just like switch the answers on me? It's like, well, let's see if this works out, guys. There you go. That'd be an interesting test to take.
hold on a second.
We can't do the standard circle.
Yeah, you can't do the standard circle.
To the logs, so, yeah, just.
But it doesn't matter that it is. What if it's log 10 and then,
So it'd be 10 to
no?
No, 'cause
What are y'all
natural
thinking?
log has a base.
Natural log has a base of e, right? So you want to put the two together first, right?
Right.
Two logs. So natural log and then x minus 2 times x plus 5, and then equals 2. And this is the part that most people get hung up on. This is really log base e, right? So e squared is this. E squared is x squared plus 3x minus 10. Do you agree? And that's where a lot of people also get stuck.
Well, I mean, you could just plug in e squared and then subtract. And you've got a quadratic, right?
Plug in e squared. No, e squared is a number, isn't it?
Yeah,
Yeah.
that's what I'm saying. You could just square that and then subtract whatever. that
Yeah,
is.
like let's get this. We're going to have to use a calculator for this. So what's e squared? Approximately. Let's just go like 2 decimal places. Yeah? 7.39 equals x squared plus 3x minus 10. And then subtract. So x squared plus 3x minus 17.39 equals 0. So I moved this guy over here, subtracted it, right?
You might want to just do the
Quadratic formula.
quadratic factors formula.
Yeah, I don't know if you're going to be able to factor that. So
I think that'll factor just fine, guys.
x equals -3 plus or minus square root.
Negative 17.39 has to give you 3. Simple math.
There it is. That should be it right there.
It's only
On
the
a
square
test, we
root of
have to
something, guys.
factor
It's
that
not
out
a
for the
big
answer.
deal.
You-
Or can we just leave it?
No, you have to figure out what that is as a decimal.
No, there's really big ones.
Relevant.
and then plug it back into the original.
And then checking will be, checking won't be so bad. So check this out. You need to figure out what this is in here. And you know it's going to be positive because you have a negative and a negative, so that's positive. So really just multiply 4 times 17.39. Figure out what that is. Then add 9 to it. Because that's what this is out here. So -3 plus or minus root. Did you do it already? 78.56. Anyone else get something like that? Anyone who's doing this? Yeah? So x is this. Now you still have to take the square root of it now. So what's the square root? 8.86. Good enough? Over 2. And now you have 2 answers, don't you? So on your calculator, you're going to have to do -3 plus this, figure it out, divide by 2. Then -3 minus this, and then divide by 2. So I think you have, what, like 5.86 divided by 2 is one answer. The other one is negative, so like negative 11.86 divided by 2. Am I doing my math right there? And then 2.93. And the other one, negative 5.93. And then we have to check those. And I've long forgotten what they were. Was it x minus 2, x plus 5? X minus 2, so will this work? X minus 2, that will work, right? X plus 5, that will work.
That one will work.
X minus 2, no, this won't work. So we only have one answer. 2.93. Yes. Could. Yes, it could happen. All right. What about this one? Natural log of x plus 1 minus natural log x equals 2. What's the difference here?
Now it's dividing.
Yeah, you have subtraction. So when you put these two logs together, you're going to actually use division. That's going to make a big difference. That's what we get, right? Now the loop thing, e squared, so it's pretty much the same so far. Equals x over, or x minus, x plus 1 over x. Multiply both sides by x. And didn't we already do e squared? Wasn't that 7.89? 29? 39? That's the left side, right? When I multiply times x, when I multiply the right side times x, I get x plus 1. That's just a linear equation, right? Subtract x on both sides. Subtract 1x on both sides. 6.39x equals 1. 1 divided by that. What do you get?
1 over 6.39.
Which is approximately 0.16, something like that. Does that work?
Yes.
Yes? Yes. So that's our solution. So when it comes to log equations, you're either going to have just the equations that are simple loop, you're done, or you're going to use that inverse one-to-one property where you match the insides. I did one of those. Or you're going to do addition between them where you multiply and then do your loop, or you're going to have subtraction between them where you divide and do a loop again. Right? So I think what you should do now is the homework. Make sure you go through all the homework for 6.6. That'll be the extent of what we do for today.
By the way, is the extra credit for cutting off one of our fingers from each hand still ongoing?
It is that will never expire. I better make sure I say I'm kidding, like have that on film. I can see myself like on CNN or something, getting interviewed by the morning show, and you offered extra credit for them to cut their fingers off, and they did. How do you feel about that?
Yeah, your juke will be up on it until this juke lasts.
I thought they understood I was kidding.
It's all fun and games until that student had to
That's
actually
right,
go for the
right.
credit.
I can.
But if
I,
someone actually did do it, would you give it? Just curious.
I would send them to the counseling center. Yeah.
You send them with the passing grade.
Yeah, I would send them to the counseling center. I'd start putting in my applications at different employers.
Why did you leave? Well, I made my
Well, my students cut their fingers off.
At least take my picture.
Yeah.
So I get my
Yeah.
points.
All right, everyone. Have a good weekend. Try and make sure you